I didn't even. Oh, what about 100? Dude, I'm so nervous. Oh, mine. The last time. No, but I heard today, today, people got it again. So it puts it in like during the 2 days. Like, I know, like, maybe like 3 and 5.
Page 8. Okay. We'll spend today talking about the second conic section, which is circles. And your quiz next Wednesday will just be parabolas and circles. So let's do some review here. You've seen this before, but we're just going to practice using it. Sometimes the problems are designed in a way where we have to use distance and midpoint formula to get to the information to build our equation for circles. So distance formula is distance between 2 points. It's basically a reworking of Pythagorean theorem. Typically it's x squared plus y squared equals e squared, but if I solve for d, square root of x2 minus x1 squared plus y2 minus y1 squared. In this case, it's not going to really matter if you flip-flop the x2 minus x1 or y1 minus y2 because it's getting squared. So if it ends up being the opposite sign, it's going to turn into a positive anyway. But as long as we subtract the x values and the y values and square them independently and add them together, we're going to get to the take the square root, we'll get the distance. Take midpoint, think of midpoint as the average between two numbers. So I'm going to find the average of the x, find the average of the y's, and that's going to be your midpoint. So I add the x together, divide by 2. I add the y's together, divided by 2. That's going to give me my midpoint. So we'll practice some of these problems using this formula here. Given 2 endpoints of the diameter of a circle, find the diameter's length. So I want to find the length between, or distance between these 2 points. I can just arbitrarily say this is x1, y1, and call this x2, y2, and I'm just going to insert it to my formula here. Okay, likewise, do the same thing for number 2. Just be careful that when you're subtracting x and y values, that if the x value, if either x or y is already a negative, you got to keep track of that negative. So just be careful about that. In this case, it really doesn't matter since if you didn't do that, you'll still get 16, but it could throw you off if this was a different, if there's a different number in front here. All right, given 2 endpoints of the diameter of a circle, find the center of the circle. So I have 2 endpoints. I'm trying to find the center, and center is just the average of the 2 endpoints. So if I'm dealing with diameter, I know that diameter is going to go through the center of the circle. So it's really always going to be the average of the 2 endpoints of the endpoints of its diameter, which will get you to your midpoint, which will be the center. So just remind yourself, though, that the operation is different between distance and midpoint. Here, we're not doing x1 minus x2 or x2 minus x1. We're finding the average of 2 numbers. So we're always going to be adding the 2 x's together, dividing by 2. Okay, so the center, or I can call it the midpoint, is 3, 6. Five halves or 2.5. Okay, so a circle is the set of all points that are equidistant from a fixed point. So, so if I have this as my center, if I can pick all the points that are the same distance away, they're all going to line up in the shape of a circle. So that distance between the center to the point on the circle is called the radius. Suppose the center of the circle is translated from the origin to a center, HK, then we can apply that distance formula and write the equation of the translated circle. So I'm just going to jump to the circle formula, really just rearranging this, replacing the x1 and y1 with h and k. And then I'm squaring both sides, and this will lead us to the equation for the circle in standard form. Instead of d squared, we're going to call it r squared. Since that distance between C and P is what we're trying to find, and that in this case, we're going to call it the radius. Kind of see that Pythagorean theorem formula basically rewritten, right? A squared plus B squared equals C squared is kind of has that that form. Okay, so H and K is going to represent the center of the circle. X and Y is any point that lies on the circle, or all the points that can live on the circle. And then r squared is your radius squared. So that's our equation of the circle. And we'll be using this as we build our equation or graph our circle. All right, let's go to the next page. Yes, question.
Why do you get rid of the root?
Oh, why did I get rid of root? Well, if I want to do this without a square root, I can square both sides. So if I square both sides, the square root and the square goes away, and I end up with d squared, and d squared is equal to r squared.
Oh,
Yeah. So I'm just squaring both sides to make it look a little cleaner. Okay, so I'm going to write the equation of the circle up here. Again, the center is your h and k, r is your radius, and then your x, y will always remain, or should always remain in your equation. That should not be replaced with a number, unless you're temporarily replacing your x and y with an ordered pair to help you find a missing information from the circle. So given the standard form for the circle, identify the center and the radius. So just like before, we're going to take the opposite sign. So what's the center for the circle?
-6.
Yep, -6, 2. Now, this number that you see here is never going to be the actual radius, unless it's 1. If it's 1, then it will be. But then if this is not the radius, we understand this is the radius squared. Okay, this number is always your radius squared. So how would I get down to the radius? Square root, yeah. So radius is 3. Okay, so the way that I sketch a circle is this. I plot my order pair, -6, 2. And then I'm just going to count up, down, left, right, 3 units. And having 4 points above and below kind of gives me some assistance in kind of mapping out how I'm going to create my circle. So my circle will just go through those 4 points. I'll just try my best to draw a circle that will hit all those points. Okay. Any questions with 5?
And you take out points if it like doesn't look like a circle behavior.
I'm sorry?
You want to take out points where it like looks like the circle looks like, like.
Yeah, so I think as you get more practice, you'll be able to kind of create that circle. But I know initially it's gonna maybe look like an oval, but I'm not gonna, are you asking like how important is it?
Yeah, outboard.
Yeah, I'm just, you're gonna try your best. I'm not going to take off once it's not a perfect thing. Okay, number 6, it's also in standard form, but it feels like it's missing something, right? What number is actually here? But we don't see it. It's really a 0, right? So, I mean, if you understand that, you don't have to rewrite it, but if you want to rewrite it in a form that feels more familiar, then you can understand that they dropped the 0 because typically just go away, but if it helps, you can rewrite it and see, okay, there's my center. Okay, so my center is -4, 0. What's my radius? Square root of 30. Okay, so we're gonna just try our best to estimate that. So, I mean, we know 5 square root of 25 is 5, so square root of 30 is probably somewhere close to 5. So if you put in your calculator, so it should be like 5 point something. Make it to a decimal, about 5.5, 5.5-ish. So from -4, 0, you're just going to go up and down, left, right, 5.5 units. Okay. Number 7, now we're given information about the circle and we're going to put it back into that standard form. So your center is HK, your radius is R. I'm trying to put it back into this form here. I'll keep my X and Y. I'll replace my H and K, but just make sure you change the what? Change the signs, yeah. And then your R squared will be what? 36, yeah. Right, go ahead and plot your center and then distance from the center 6 units and create your circle. Okay, now number 8 is a little bit different because you have a center, which is HK. But it passes through a point. And what does that point, you think, represent?
Yeah.
It's just some random point on the circle, but it does constitute as a specific version of an XY. So if we have HK and XY, we can kind of temporarily just plug into the formula to solve for R. And once we solve for R, we can go back and put it back into the standard form. So we're just inserting our HK and XY temporarily, using it to solve for R. Once we get to R, then we can backtrack and put it back into standard position. our standard form, and we can drop that 1, 2. That 1, 2 is no longer going to be used. Okay, so just again, just like before, when we did that yesterday with parabolas, that you don't change the signs for x, y. Okay, change the sign for hk to the formula, but x, y will stay the sign that you see there. So now we're just trying to solve for r. We don't know what r is. Once we get to r, it'll be more familiar. Okay, 9 plus 16 is 25. 25 is r squared, therefore r is 5. Okay, so now all we need is the center and the radius, and we can build our circle equation. Yeah, question.
Use the distance function. So, right.
Exactly right. And this is, your circle equation is kind of like distance formula. So, yeah, you can use distance formula to get to, but it's just nice to just be able to use one equation to get to r squared as well. So it's up to you. It's the same thing. Yeah.
Same thing, I use Pythagorean theorem, got the same.
There you go. Yeah, Pythagorean theorem, distance formula, circle, they're all kind of connected. So, yeah, they're all essentially the same equation. So, yeah, any of those three works. It's going to be a little bit off the grid here. Okay, now we want to write the equation for our circle. So x plus 2 squared plus y minus 6 squared equals r squared. And now when you put it back into standard position, we don't want the x, y with numbers, right? We want to hold on to the x, y variable. So the 1, 2 is just temporary information to help us get going, but we're not going to keep it at the end of our answer. Okay, any questions so far? Okay, so the center is at -3, -2, and it's tangent to the line y equals 5. Okay, so let's draw this out, kind of visualize this a little bit here. So center is at -3, -2. Okay, there's the center of my circle. And then the line y equals 5, that's a vertical or horizontal line? Horizontal line, yeah, y equals 5. I'll put a dotted line at y equals 5 just so we can kind of visualize it. So what this is telling us is that if it's tangent, that means this circle is going to skim the surface of that dotted line. And so if I know that, then I kind of know what value. Yeah, that's my radius, exactly. So I know that if it's going to touch that line, I know that distance is going to be my radius. If I just count it and get my radius here. So 1, 2, 3, 4, 5, 6, 7. Right? So my radius is 7. So that means I can count from the center 7 units in the other directions as well, and I can create a circle that's going to skim the surface of that y equals 5. Okay, let's write our equation. We have our HK, we have our radius.
equals r squared. 7 squared is 49. Is my equation. Okay, number 10. The endpoints of the diameter is negative 2, 1, and 6, 7. So negative 2, 1, 6, 7. So these are going to be the endpoints of the diameter. So the circle will look something like this, but I know that what can I use these to help me find? The midpoint. Yep, the midpoint will be my what of the circle? Center. Yep. So if I do midpoint formula, I get to my center. Once I get to my center, then I can use Pythagorean theorem or distance formula or put it into the circle equation, similar to this problem then. So you're going to feel like, oh, I'm just going to find my radius after that. Okay, but let's go through midpoint first. So I'm going to be adding my x values and dividing by 2, adding the y values and dividing by 2. So I have 4 over 2, which is 2, 8 over 2, which is 4. So I'm going to plot that point. My midpoint or my center is at 2, 4. Now we can't quite count diagonally and know what the unit is. It's not as clean as if it was along a vertical. So we can, a number of different options, like you guys mentioned, Pythagorean theorem, distance formula, or I'm just going to rely on the circle equation since I have that in front of me. So I'm going to treat this like my HK, and I can treat either one of these as my XY. Both these points are points that lie on the circle, so it doesn't matter, but I'm just going to use this strategy here, use my XY and HK to solve for R. Once I solve for R, then I'm able to create my standard equation. Again, there are multiple ways that you can get to your answer, but this is the way I'm going to do it. Okay, so replace HK with 2, 4, and I'm just arbitrarily choosing 6, 7. You can also choose negative 2, 1 for XY as well. Either way, you're going to get to the same answer. Okay, so 6 minus 2 squared plus y minus k squared. So r squared equals 25. R is 5. So that's all I need. All I want is my R and my center, and that's all I need to create my equation. I don't need these points anymore. These are just temporarily helps me get to what I need. All right, let's go to page 10 and 11. Okay, so here are the classwork. Let's do numbers 1 and 2. And then on page 11, we'll do all of it, 5 through 11. Those are the more important ones I want us to practice with. Okay, so I'll work through it the same time that you guys are doing it, 1 and 2, and then 5 through 11 all. Page 10 and 11. Page 11, all 5 through 11.
Do you see y squared for like how answer if you want to? This one,
Um,
like the equation.
Yeah, it's equivalent, so yeah, that should be fine.
Yeah, 11 takes the longest because you have to use the midpoint to get to the center. Once you get to the center, you're gonna pick a point and the center to help find the radius, and after you get to the radius, then you can create your standing position. Okay, give me a few minutes for students to finish up, and then I'll let you guys get your phone. Just wait a few minutes.
For 11, so that's plugged in the second point.
Yeah, exactly.
Okay.
Like 7 point, you should get the same answer. You should get the same radius. Monday, we're gonna look at circles, having to complete the square. But it should come pretty easily since we've already done that with parabolas. The only thing is we have to maybe complete the square twice, once for the x and once for the y, so it may add the formula may take a little bit longer to get through, but we know the concept. So Monday, we'll finish up circles. We can start review. Tuesday, we'll have full class period for review, and then Wednesday quiz, just over circles and parabolas. Okay, I think I'll get your phones.
Dude, I'm gonna. I can do these with the pen.